Hello, everyone. Welcome to the Mathematician's Den. This is the Herm Dog, and we're going to do some more related rates questions today. I want you guys to find the rate of change in the angle of elevation of the camera. And by the way, the camera would be right here, 2,000 feet away from the launch pad in this figure. And I want to know what that angle of elevation is doing 10 seconds after liftoff. And if you see the S in the flames there, S is equal to 50t squared. Ladies and gentlemen, it says, I want to find the rate of change in the angle of elevation. What is that? That, ladies and gentlemen, is d theta dt. The rate of change in r is dr dt. The rate of change in height, h, is dh dt. The rate of change in theta is d theta dt. I need an equation that involves theta. So I've got an angle. I've got sides. Here we go. We're going to do some trig here. It looks to me like I have the opposite side s and the adjacent side 2000. So I'm going to use tangent of theta is equal to s over 2000. But wait a minute, s, ladies and gentlemen, is actually 50 t squared. And this is going to reduce. Tangent of theta is going to be t squared over 40. So what's my derivative? Now we got to be careful with our derivatives. The derivative of tangent is secant squared of theta. But ladies and gentlemen, the derivative of theta with respect to time is d theta dt. The derivative of the other side would be 2t over 40, and that is going to reduce to t over 20. So let's solve this for d theta dt. I have a t over 20 on the other side when I reduce, and to get rid of that secant, I could divide by secant squared. But wait a minute. Secant is 1 over cosine squared. So technically here, when you divide by secant, you are multiplying by cosine squared. So there's my formula that I can use, my derivative. Notice I didn't plug in t equals 10 yet. I don't want to plug in t equals 10 because t is changing, time is going on. It's going on and on and on, it's changing. So I don't want to plug in 10 until after I take the derivative. In fact, I'm going to do that now. I am going to choose a different color here. For d theta dt, I'm going to plug in t equals 10, so this would reduce to 1/2. What's cosine? Well, cosine is the adjacent side over the hypotenuse. Well, I know the adjacent side is 2000, but what's the hypotenuse? The hypotenuse, well, I know s is equal to 50t squared. S is equal to 50 times 10 squared. That's 5,000. Now, I could do Pythagorean theorem here. I could do 2,000 squared plus 5,000 squared equals the hypotenuse squared. Let's call that h squared. And by the way, do I really need to use thousands? I could do 2 squared plus 5 squared equals h squared. You'd figure out pretty fast that h in this problem is radical 29. But since I started out with 2,000, 5,000, this is radical 29 times 1,000. So the hypotenuse, and I've got to fix my fraction here, my hypotenuse is going to be, I need a darker color than that, 1,000 radical 29, and on the top I've got 2,000. Ladies and gentlemen, that reduces to 2 over radical 29. And that means cosine squared of theta would be 4 over 29. So I just have to multiply this by 4 over 29, and look at this. I've got my answer for d theta dt, and I have not touched a calculator. Just because it's trig doesn't mean you got to touch a calculator. This reduces to 2 over 29. Now, we need units. What are my units for this question? Well, it's units for angles over units of time. Time in this problem was seconds, so this is something per second. Most people are going to say, well, it's degrees. Whenever you're dealing with distances and angles in a calculus question, the angles are measured in radians. So this would be radians per second. It's 2 over 29 radians per second. Please remember, in calculus, if you're dealing with angles and sides in the same question, you've got to use radians. So this is a great trig problem where we could solve it without a calculator. Now, this shadow problem is really a popular question that I've seen in several books. I've even seen several different teachers use it on their test at the college level, at the high school level. You have a man that is 6 feet tall right here that is walking at a rate of 13 feet per second away from a light that is 18 feet above the ground. When he is 12 feet away from the base of the light, at what rate is the length of his shadow changing? At what rate is the tip of his shadow moving? Now let's put some variables in this question. And here's the thing about variables. Here is the distance he's moving along the ground. How far has he moved? And most people are going to say, well, he's moved 12 feet. No, he's moved 12 feet, but he keeps moving. So I have to write this as a variable. I'm just going to call that x. X is how far he's traveled. So that means the rate of change in x, dx dt, is how fast he is moving. He's moving 3 feet per second. Would this be positive 3 feet per second or negative 3 feet per second? I'm going to tell you right now it's positive because the distance is getting bigger. Now, just to stay consistent with my variables, I'm going to call the length of his shadow, and I don't like to use S. It looks too much like my fives. I'm going to call the length of his shadow Y. And I'm going to call the distance all the way from the light to the tip of his shadow, I'm just going to call that W, because my Z's look too much like 2's. So this is all the information I have so far. What's the length, the rate at which the length of his shadow is changing? Ladies and gentlemen, the length of his shadow is Y. So the rate at which his shadow is changing is dy dt. That's what I need to find in part A. The rate at which the tip of his shadow is moving, well, the length to the tip of his shadow is W. So dw dt would be the rate of the tip of his shadow. So I need something that involves x, y, and z. Well, actually, that's pretty easy. X plus y equals, I'm sorry, not z, w. I have an equation. X is changing. If the man keeps moving, his shadow is going to keep getting bigger, and the tip of his shadow is going to keep moving. So all three of these variables, I'm not going to plug in anything for these variables. The derivative of x is dx dt. The derivative of y is dy dt. The derivative with respect to time of w is dw dt. And there's only one of those variables that I know right now. Which one is it? I know dx dt is 3. Now, what this means is I need another equation that involves y and w. I don't really need x. I need y and w. And this is where a lot of my students get stumped. They're like, what am I looking for? If you notice in this picture, I've got a big right triangle involving the 18 and the w as the vertical and horizontal sides. I've got another smaller right triangle here with the 6 and the y as the vertical and horizontal sides. What kind of triangles are those? Those two triangles are similar triangles. Ooh, we're throwing in a little geometry here. What do you know about similar triangles? They are proportional. The vertical side 18 to the horizontal side W in the big triangle would equal the vertical side 6 in the smaller triangle to the horizontal side Y. This is the proportion from those similar triangles. Vertical to horizontal equals vertical to horizontal. Cross multiply, I'd get 18y equals 6w. Divide by 6, I'd get 3y equals w, and guess what? I can take the derivative of this. The derivative would be 3. The derivative of y with respect to time is dy dt. The derivative of w would be dw dt. And notice what I can do. I can substitute this in for dw dt over here, and I've got a whole new equation. I've got 3 plus dy dt equals 3 dy dt. Now I can solve for dy dt very easily, as a matter of fact. Subtract the dy dt, I would get 3 equals 2. dy dt. And if I divide by 2, dy dt is 3 halves. And what would be the units? Well, y would be measured in feet. The time would be measured in seconds. Your shadow is changing 1.5 feet per second at that instance. Well, how do I find dw dt? Well, if dy dt is now 3 halves, couldn't I plug it in right there and multiply it by 3? dw dt would be 3 times 3 halves, or 9 halves feet per second. The tip of your shadow would be moving 4.5 feet per second. Heck, I could have plugged that 3 halves back in up here and solved as well. 3 plus 3 halves is 4.5. And again, this is a very popular question with related rates because it involves not just one equation. It involves two. It involves not just finding one missing variable. You have to find two. I hope you liked this video. If you did, please like and subscribe. Hit those buttons, please. I'll be posting more videos later on.